Hello and welcome. In this video segment, I'm going to present an overview about reference features within Catia v5. So let's get started. Reference features are objects that you commonly use to construct a model. There are four types of reference features: reference planes, reference lines, reference points, and axis systems. A reference plane is a feature and object that represents an infinite plane in space. You can define a reference plane using 3 points, 2 lines or edges, a face, by defining its normal vector, or by defining the plane equation. You commonly use reference planes as a placement face for features or sketches. They are also useful for positioning features, constraining sketches, or splitting solid bodies. Reference planes are infinite in size. The display that you see in the graphics window serves only as a reference, and to allow for the selection of the feature. A reference line is a feature and object that represents a vector in space. You can define a reference line using 2 points or a single line or edge. Reference lines are commonly used to define the reference direction of a feature. They also help to constrain a sketch or define a rotational axis. A reference point is a feature and object that represents a point in space. You can define a reference point using coordinates on a surface, plane, or edge. Reference points are commonly used to define positions along objects, such as splines or curves. They are also useful as construction elements. An axis system is comprised of a coordinate system, a reference point, 3 reference planes, and 3 reference lines. These combine to form one axis system but behave as individual items depending on the application. You can select each of the components as reference geometry for most operations. This is an advantage over reference planes and lines, since it is a single feature rather than 7. When you open a new Catia part file, there are 3 reference planes automatically set up at 0, 0, 0. These are fixed in space, though they can be hidden using the View, Hide Show, or simply right-click and select Hide Show. A set of fixed reference planes is ideal for starting a model. You can use these fixed planes to create a sketch that may represent the profile of a model. You can also reference these planes throughout the model in order to create a well-built parametric model. Reference features are commonly used to place, orient, and position features. Because of the flexibility in creating reference features, they become vital tools in creating models. Planes are commonly used as placement faces for sketches and other features. A fixed reference plane makes a good placement face for the first sketch of a model. This reference plane can then serve as a common reference for several sketches and features in the model. Reference planes can simplify your model by taking advantage of the parent-child relationship of the plane to other features. For example, you could have a road guide sketched on a reference plane. By modifying the angle from 45 degrees to 75 degrees, you can relocate the entire road guide. You can use reference features to define the reference direction of a feature, such as a circular pattern or a pad. This is useful in cases where an edge is not available. In addition to reference lines, you can use reference planes to define the reference direction. Picking a reference plane for a rectangular pattern automatically defines the 2 reference directions according to the positive axis directions. In general, picking a plane as the reference direction sets the direction as the normal of the plane. You can use reference planes when splitting solids. Using a reference plane as a trimming plane for a split solid allows you to easily edit the solid by moving the position of the plane. Reference features can also be useful in assemblies. When there are no suitable faces or edges to use in constraining components together, you easily create a coincidence, offset, or angle constraint between two component reference features. The ability to capture design intent is commonly referred to as parametric or variational modeling. With the parametric features in Catia, you must make careful decisions when creating the model in order to define the design intent and take full advantage of Catia's parametric abilities. That wraps up this video. Thanks for watching. See you soon.